Hello friends, in this class we're going to talk about the forces. First of all, force is a vector quantity. So force is a vector quantity. So what do we mean by vector quantity? It has direction as well as magnitude. So the units of force is newtons. And now let's take an example. So if I say force equal to 50 Newton acting upon a body, is this sufficient? No, the 50 Newton only represents the magnitude of the force, and then I have to specify the direction in which the force is also acting on the body. So if the force is acting in east direction, north direction, or west direction, in this case I have taken the assumption as east direction. Because it's a vector quantity, so we will apply all the rules of vectors on this one. So if I have to represent, this is east, so I'll represent the force in the east direction. This is 50 newtons in east direction. Now let's take another example of force. So if this is an object, the weight of this object is, let's say, m, and I apply a force of 50 newtons in the forward direction, and then there is an opposite force also being applied by my friend, and which is 30 newtons, and I'm gonna assume this is a frictionless surface. There's no friction on the surface. So what is the net force? So net force, that's what I wanted to find out. So net force will be, F net will be equal to, you'll say 50 east, you will add, because this is a vector quantity as I said, so I'm going to apply all the vector rules into this one. So rather than writing this, I'll write down as F1 plus F2. I'm going to name this as F1, name this as F2. And then this is 50 plus minus 30 negative because it's acting in the opposite direction. So this will be 20 Newton force acting on the net force acting on the object. Now let's say there's one of my friend wants to help me, and he starts applying 30 newtons in the forward direction also. So I wanted to find the net force acting on the object now. So F net will be equal to, again, sum of all the forces, F1 plus F2 plus F3. So that's what it will come down to as 50 plus 30 minus 30. This will be F net, comes out to be F net value will be equal to 50 newtons, but I have to specify the direction because this is positive, so east. This was positive, so this was also east. So these were the one-dimensional problems on the forces. So in real life the problems are not so easy, or in the books you'll also see that problems are a little more complicated. Let's say this is the object. Now one of my friend is applying a force in this direction. He's applying a force of 30 newtons, and another friend of mine is trying to pull this object in the forward direction. He's applying the force of, let's say, 40 newtons in this direction, and a third of my friend, my third friend shall I say, my third friend is applying the force of, let's say, I'm gonna call it as 40 newtons in the opposite direction. And this is this body is placed on a frictionless surface. I wanted to see whether this object will move or not. So again, I'm gonna apply the two-dimensional vector concepts on this one. So if this vector, I can say that this is a 2D vector with respect to this horizontal surface. So I can find the component of this vector in the east direction and find the component of this vector in the north direction. So let's say this is acting at an angle of, I'm going to assume as 30 degrees, and I'm going to assume this angle as, change the angle, I'll change it as 20 degrees. And this is acting along the west direction. There's no angle for this 40 Newton force. So I'm going to find the component of 30 Newton force. So this will be 30 cos 30 degrees, which comes out to be 20. This component comes out to be 25.9, and the component in the y direction will be 30 sine 30, that will be 15. So this component comes out to be 15. And now I wanted to find the components of this 40 Newton force. This is, I'm going to call it as F2, this one was F1, and this is F3. So component of this in this direction, oops, I need to change the color so that you guys don't confuse yourself. So this, oops, this will be better color. So this component, and then there is this component. So this is 40 cos 20, this is 37.58 Newton force, and then there is a vertical force in the vertical direction that will be 40 cos 40 sine 20, 13.6. This is 13.6. Now I'm going to resolve the component resolve these forces in x and y direction. So I'm going to write down, change the color, F net in x direction, that will be equal to F1x plus F2x plus F3x. So for F3 there is only x component, there is no y component, so F3x or F3 will be the same values. So this is this value is 25.9 plus 40, both are acting in the forward direction or towards the east, so that's why I've kept it as positive. This 40 Newton is acting in the backward direction, so I'm gonna call it as negative force. So this value is actually F2x is not 40, this is 37.58. I'm gonna call it as 6, 37.6. 25.9 plus 37.6 minus 40 will give me 23.5 newtons F net x direction, and then I will find F net in y direction. This value will be the force, one is acting, 15 Newton is acting in the north direction, so 15 positive, this is 13.6 is acting in the downward direction, plus minus 13.6, and there is no vertical component of this 40 Newton force, so plus 0. So this will be 15 minus 13.6, that's gonna give me 1.4 newtons F net y. So I have the component of force in y direction, component force in x direction. This is positive, so that's why this is in the north direction. So I'm going to draw again on the vector diagram, and so this will be north 1.4, and then this will be how much? 23.5 in x direction, again positive value, so I've drawn it in the east direction. This will give me the resultant value. I'm going to replace this value over here, 1.4, so 1.4 square plus 23.5 square, and square root answer will give me, this value will come out to be 23.5 newtons. And I can also find this angle. So this angle will come out to be, this angle is theta, which is tangent theta is equal to 1.4 divided by 23.5. Theta value is equal to tangent inverse 1.4 divided by 23.5. That value will be 1.4 23.5. Second function, tangent inverse, answer, that's gonna be 3.4 degrees. So F net is equal to 1.4 newtons at an angle of 3.4 degrees. I can call it as north, I can call it as north of east, because this is east, this is north, so this is my final answer. So this was the basics about the how to calculate the net force when there are multiple forces given to you in one dimension or in two dimensions. Now we're going to go back and look into the laws of forces. So Newton gave 3 laws for the forces. Newton was the inventor, you can say inventor of these forces. Newton was the first person who discovered the formulas for these forces. So he gave 3 laws: first law, second law, and third law. So first law says that the object will not change its position until or unless it is acted upon by some external force. So for what do I mean by that? So if there is a car if there is a car which, oops, why I'm drawing the circles here, so these are the circles I should have drawn here. So if the car is moving in the forward direction, it will keep on moving in the forward direction until or unless it is acted upon by some external force. So assume this is a toy car. This will keep on moving in the forward direction until or unless it is acted upon by any external force. It'll just keep on moving. You'll say to me, but it stops after a certain time. So what happens in that scenario is there is force of friction which is acting in the opposite direction. That's why this car stops. Otherwise this car will never stop if there is no force of friction with respect to the ground. If you throw this car in space, it will keep on moving, because in space there is, out of Earth, there is no force of friction. Okay, so that was the Newton's first law. Or in the other scenario, if the object is on the rest condition, if this is a toy car which is under the rest condition, it will stay on the rest condition until or unless it is acted upon by external forces. Now the second law, the change in the acceleration happens in the direction of the motion. So if this is a car which is moving in the forward direction, and if I accelerate the car, if I throttle the pedal, so what's going to happen? Car will start moving with a much faster speed. So car will accelerate. Let's say this is moving in the east direction, car will start accelerating in the east direction, because the now force is being applied in the forward direction. So that's why the car will also accelerate in the forward direction. I shall say in the direction, not in the direction of motion, in the direction of force applied. Force applied. Now you can take another analogy rather than throttling the car with the engine. So you're driving this car, a kid is driving this car, and you apply the force from behind. Okay, if you apply the force, what's going to happen? Car will accelerate in the forward direction. And if a kid is approaching towards you in his car, and then you're trying to stop him, so you'll apply the force in the opposite direction. So the car will start decelerating. So acceleration will be in the opposite direction. So that's what the second law says. Change in acceleration happens in the direction of force applied. Then the third law. This is very simple and one of my favorite laws. It says that every action has an equal and opposite reaction. What does this mean? That if you think about this with an analogy, if you're gonna slap someone, someone's gonna hit you back also. So that's according to the Newton's third law. So let's take more of a more scientific approach. So if this is a wall, okay, and then I hit this wall with 50 newtons of force, although this wall is not alive, but I'll feel the force. Why? Because I will feel the equal amount of force being applied back on me, which will be 50 newtons in the opposite direction. So every action has equal and opposite reaction. Another real life example for this one will be walking off any mammal in this world. Let's take an example of human beings. Why we've been able to walk? Because when a human is trying to walk, he's trying to press, he applies the force in the forward direction, which gives him the lift. That's why he's been able to move in the forward direction. Think about this. If you're trying to walk on the water, you can't walk on the water. So hopefully you were able to understand some basics about the forces. I'll talk about some more detailed concepts in the next class. Thanks for listening. Have a good day. Bye. Oops.